this angle is always going to be 90 degree. We keep on getting different circles, but all of them are passing through focus. All these lines are focal chords except for the one, and it is tracing out a vertical line, I think. And you can see that all these circles are not crossing this label on left side. And here you can see their centers are tracing out a curve, which is obviously a parabola. And it seems like JEE Advanced or JEE Main 2021 both were asking questions on the same property of this parabola. In the next 15 minutes, we are going to discuss two important properties of parabola, and we are going to see how by applying them in questions, we can solve the questions at very fast speed. Let's see the property first. First property. This is our x-axis, this is y-axis, this is our parabola in standard position. You can assume that equation is y square is equal to 4ax. Focus F, vertex A, directrix x is equal to minus a. Now we take a point P on the parabola. This is point P. We draw a tangent. It is going to cut the directrix at some point. Let's call it Q. This point is Q. Now what about this portion PQ intersected between the point of contact and the directrix? If we join these 2 points P and Q to the focus, then this angle is always going to be 90 degree. That is a standard property. That means this always happens. This is not just because of some particular position of P or Q. If we change the position of P, let's see what happens. Here we are changing the position of P on the parabola, and the angle subtended by this portion of the tangent between the point of contact and directrix is always 90 degree at focus. So that is the first property. The portion of tangent to the parabola intercepted between the directrix and curve subtends right angle at the focus. And the same property, we can talk about that in a different way also. This is a right angle at this point F. So if we draw a circle with PQ as diameter, it is going to definitely pass through the point F. That means the same property can be restated as the circle drawn with the portion of tangent to a parabola intercepted between the directrix and the curve passes through the focus, and that will also happen always. So we draw a circle, it is passing through focus, and if we change the position of P, we keep on getting different circles, but all of them are passing through focus. There is no change if we are changing the position of P regarding the property that circle is going to pass through the focus. It is. Okay. So this was about the portion of the tangent intercepted between the point of contact and the directrix. Second property, this is about focal chords. Focal chords means the chords which passes through the focus of the parabola. For example, this is one particular focal chord with endpoints P and Q. This is a focal chord. There are infinite number of focal chords. Any chord which passes through the focus, that will be called a focal chord. So you can see all these lines are focal chords except for the one which is like passing through vertex also, which becomes the axis. That will not be a chord as it is not going to intersect the parabola at other point other than the vertex. So these are all focal chords. Now what is so special about the focal chords? Let's see. We again draw a focal chord, and this time let's name it same. Endpoints are P and Q. Now what we do, we draw a tangent at point P and point Q. They will be intersecting at some point. This angle is going to be 90 degree always. If this point is T, then angle at T, that will be always 90 degree. And this will also be true for all positions of P. If we change the position of P, we can see this point T is moving and it is tracing out a vertical line, I think. And this angle is always maintained 90 degree. There is no problem with that. Whatever is the position of P, this angle is 90 degree. And what is this path on which T is moving? This is focus, this is vertex, and this seems to be at the same distance on the left side of this vertex. So that must be directrix. If you were also thinking the same thing, then you are absolutely right. This point T always lies on the directrix. So point to remember, the tangents at the endpoints of a focal chord intersects at right angle on the directrix of the parabola. Okay. Now here again, if we draw a circle with PQ as the endpoints of diameter, that is going to pass through the point T. That is very obvious. Diameter subtends right angle at any point on the circle, in fact. So that will be subtending right angle at point T also. If you draw a circle like this, will that circle be intersecting that directrix again at some point or not? Let's draw it and see. Point P, focal chord, endpoints PQ. Again we draw a circle with PQ as diameter. If we change the position of P, let's see what happens. Now P is changing position on the parabola and all these circles are there, and you can see that all these circles are not crossing this label on left side. That is, there is some vertical line to which all these circles are touching, and no points for guessing that is the directrix. All these circles for all positions of P and Q will change automatically for keeping the PQ a focal chord. So all these circles are going to touch the directrix. That is second point about this property. Any circle or focal chord as diameter touches the directrix. Good enough. Let's see one more thing about this. Again the parabola and PQ, the focal chord. Now this part FP, that is the line segment joining focus to the point on the parabola, that part is called focal radius of this point P. So this segment is the focal radius of point P. This is focal radius for point Q. If we draw a circle on this focal radius of point P as diameter, then what about that circle? Obviously center will be the midpoint of PF, that is this point R. What about this circle? If we change the position of point P, let's see what happens. Here you can see we are getting different circles with this part PF as diameter, and all these circles are also not crossing a line, vertical line. And what is that line? Obviously this is perpendicular to line joining AF and passing through A, so that must be tangent at the vertex. That is to remember this thing. The circle drawn on focal radii of any point as diameter always touches the tangent at vertex. That's what we have written down over here. Now this was about the focal radius of the point P. What about the other endpoint of the focal chord, that was Q? Let's see. Again we draw that line and this is point Q. What about the circle we draw on this line taking QF as diameter? Let's draw the circle and let's change the position of point P again, and let's see what happens to this. Again the same thing is happening. All these circles are also not going to cross this level, this vertical line, which was in earlier case that was tangent at vertex, and in this case also that line is tangent at vertex. So this circle will also be touching the tangent at vertex. What about the centers of these circles? Those two circles we talked about, one on FP as diameter and other one as QF on diameter. These two circles, their centers are R, midpoint of FP, and midpoint of QF, that is S. R and S are their centers. Let's see what happened to their centers when we move the point P on the parabola for different positions of P. And here you can see their centers are tracing out a curve, which is obviously a parabola. That is a parabola. So we can say that The loci of the centers of the circles with focal radius as diameter is a parabola. In fact, this parabola is having vertex at the midpoint of this vertex and focus of the original parabola, and its length of lattice rectum, that will be half of the original parabola. Now let's see what type of questions can be answered using this. First is from JEE 2010, very old question, around 15 years back. The questions were very straightforward. If two tangents drawn from the point P to the parabola y square is equal to 4x are at right angles, then the locus of point P. We don't have to draw any diagram or anything else. Tangents drawn from point P to the parabola are at right angles. That means that point is going to be lying on the directrix of the parabola. And pay attention to this fact also. The tangents at endpoints will intersect at right angle on the directrix, and vice versa is also true. From any point on the directrix, if you draw two tangents to a parabola, they are going to be at 90 degree, and their chord of contact, that will be focal chord for the parabola. So here answer is obviously the equation of directrix. A, comparing it with the y square is equal to 4a, a is equal to 1 here. So directrix is x is equal to minus a. That means x is equal to minus 1. That should be the answer. And that is correct. Now let's move a little ahead, and that is JEE Main 2021. Let's see here. If two tangents drawn from a point P to the parabola y square is equal to 16 into x minus 3 are at right angles, then locus of the point P. Okay, two tangents drawn from point P are at right angles. That means that point is going to be lying on the directrix of this parabola. And here it is y square is equal to 16 into x minus 3. That means its vertex is shifted to 3, 0. So it will be looking like this. This is 3, 0. And y square is equal to 16. That means a is equal to 4. A is equal to 4. That means directrix is going to be from this point at a distance of 4 units on the left side. So that will be 3 minus 4 minus 1. That means x is equal to minus 1 is directrix for this, and all these points P will be lying on that directrix. So answer is x is equal to minus 1 or x plus 1 equal to 0. And tangents will be mutually perpendicular from any point on this directrix. So answer is third option. So reusing properties, sometimes questions can be answered like this if right property strikes you at that time. Let's see one more question from JEE Main 2021, and this time this is forwarded in a different way. Let a parabola P be such that its vertex and focus lie on the positive x-axis at a distance of 2 units and 2 units from the origin. So vertex is 2, 0, focus is 4, 0. If tangents are drawn from point O 0, 0 to this parabola, which meet at S and R, then area of triangle SOR is equal to, let's see. Let's take a help of a diagram. This is 2, 0, this is 4, 0. Vertex, focus, distance between focus and vertex. Let's draw the parabola first. This is the parabola. Vertex, focus, this is distance between the two, that will be equal to 2. So this gap is 2. So 2 units on the left hand side, this is 2, 0, so that will be 0, 0. Directrix will be passing through this point. That means y-axis is the directrix. And the point O, that is the origin. From there, if we draw two tangents, they are going to look like this. And this point lies on the axis of symmetry of parabola. So these 2 points, the upper point of tangency and this lower one, they are also going to lie on a vertical line passing through focus. So that means this line is actually lattice rectum. So in terms of general terminology, if this is y square is equal to 4ax type, then this length is 4a, and this length, this is directrix and this is focus, that is equal to 2a. 4a multiplied by 2a, that is 8a square base into height, that is going to be the area of this triangle, which we are expected to find in the problem. So this area 4a into 2a, 8a square divided by 2 also. So that will be 4a square, and a is equal to 4. So 4 into 4, 16. That means first option is the correct answer. You don't have to do any calculations or write down any equations if you observe that this property is applicable in this situation. Now let's take a question from JEE Advanced. This is JEE Advanced 2021 paper 2, and it seems like JEE Advanced or JEE Main 2021 both were asking questions on the same property of this parabola. Let's see what is given here. E denotes the parabola, the typical style of JEE Advanced, long language, and then you have to understand it. E denotes the parabola y square is equal to 8x, okay, y square is equal to 4x, a is equal to 2. P is equal to minus 2 comma 4 and Q dash be two distinct points on E such that PQ and PQ dash are tangents to E. Let F be the focus of E, then which of the following statements are true? Let's draw a rough diagram. Here y square is equal to 8x, that is standard position parabola, vertex at origin. So vertex at origin, let's say this is y square is equal to 8x, a is equal to 2, so this point minus 2 comma 4, this will be lying on the directrix. X is equal to minus a, that is the directrix. So this point given here, given to us, is lying on the directrix, and that is the most important observation in this question. Once you observe this thing, now you know what is going to happen. From this point we draw two tangents, one going like this and other one like this. This point of tangency, let's call it Q, and this one let's call it Q dash, and this is point P, and focus that is going to be on the axis somewhere around here. So that is focus. Now look at the options. The triangle PFQ is right angle, so we need to join P to F and F to Q. Is this angle, this triangle is right angled? Obviously it is right angled. As per the first property, the portion of tangent intercepted between the point of contact and directrix subtends right angle at the focus. So this angle is going to be 90 degree. So this is a right angle triangle. First option is correct. Second one, the triangle QPQ dash. QP and Q dash. Let's complete it. This triangle we are talking about. Is this a right angle triangle? As we have drawn tangents to this parabola from a point on the directrix, the chord of contact, that is QQ dash, that is going to be a focal chord, and endpoints of focal chord subtends right angle at this point P. So obviously QPQ dash, that is also right angle triangle. This is 90 degree. Third option is very easy to check. Point P is given to you, minus 2 comma 4, and focus has got coordinates a comma 0 and a is equal to 2, so 2 comma 0. If you obtain the distance between these two, that will be 16 plus 16, 32. That means 4 root 2. That will not be 5 root 2. That means third option is incorrect. So we have got first option, second option correct, and third incorrect. F lies on the line joining Q and Q dash. Obviously this Q and Q dash is going to be a straight line, as this is chord of contact of this point and this is focal chord. So third option is, fourth option, that is also correct. So that's how you can use these properties while solving the problems from parabola, and similar properties are there for other conic sections, which we will be discussing in coming up videos. Thanks for watching this, and don't forget to like and subscribe.